decimal to binary, conversion from hexadecimal to binary, conversion from decimal to hexadecimal, right? And conversion from hexadecimal to decimal, and conversion from binary to decimal, and conversion from binary to hexadecimal, and conversion from and if a computer, very important point, part is this one. If a computer is 8-bit machine, then how do you convert it from binary to decimal if a computer is 8-bit machine? Okay, so that we'll discuss it now. So first we'll take conversion from decimal to binary. So bit position, this is what this is the bit position. Okay, so you had to start from right towards left in this reverse order. Okay, first you write 1 starting from 1, 1 to the 2, 2 to the 4, 4 to the 8, 8 to the 16, 16 to the 32, 32 to the 64, 64 to the 128, like that. 128 to the 256, you can add, you can keep, it keeps going. Okay, and here, why did I multiply this one with 2 only? Because this is binary. Binary means what? Bi stands for 2. Okay, 2 values, that is zeros and ones. That is the reason multiply 1 by 2. 2 1 to the 2, 2 to the 4, like that. So next, here decimal number 25D. Okay, how do you convert this decimal number to binary? Here, so first, if wherever you see the what is that, these decimal numbers, okay, there you put 1. Okay, so if you see this one 16, I cannot put 30, I cannot put 1 here because 32 is greater than 25, so that is why I cannot put 1 under 32. So put this 1 under below, just below the uh, 16. 16 plus 8, 16 plus 8 is 24, so 24 is however less than 25, so add one more 1, so that is now it becomes 25. 16 plus 8 is 24, 24 plus 1 is 25. So now rest, what about remaining numbers? It is becomes 0, 0, 0, 0, right? And now 16 plus 8 plus, yes, and this is also 0, and this is also 0, and this is 1, right? So this is how we write numbers. Okay, so let me give space now. Fine. So now this is what binary equivalent of 25D. Okay, so now how to represent this is equal to 0 0 0 1, right? And 1 0 0 1 D. D stands for decimal. Okay, D stands for decimal. And next, similarly 53D. 53D, how do you write 53D now? 31st starting from 32. Okay, 64 is greater than 53, so I don't write this one, that one, binary bit 1. So first you write okay, however this will become 0. First let me finish this. 32 32 32, put 1 there. Next, 32 plus 16 is what? 50, sorry, 48. 48 is 32 plus 32 plus 16, 48. 48 plus 8 is 56. So it exceeds 53. So don't put 1 below 8 position. Next, 48 plus 4 is what? 52. 52 plus 1 is 53, and rest all zeros. Here put 0, and 64 put 0, and here put 0, and then 0, right? So now this is equal to 0 0 1 1 0 1 0 1. So Now you try this out. So how do you write 127D in binary? How do you convert 127D in binary? Okay, please answer that and please comment below. Okay, and next, so this is question mark now. Yes, and next, conversion from hexadecimal to binary. How do you convert hexadecimal to binary? Bit position. This is the bit position. Binary bit position means bit stands for binary digit. Okay, bit means binary digits. Binary means 0 or 1. So this is what decimal positions of our binaries. Okay, starting from 1 to 4 like that, from right towards left. Okay, and then here how do you convert this hexadecimal number? Now 32H is what? Hexadecimal number. How do you convert this 32H hexadecimal number to binary? So where first take first digit, that is 3. This 32H is what? It has 2 digits, 1 3 and second one 2, right? So first convert this 32H to binary. So now what I will do, I'll just remove this, okay, and I'll replace it with 8421. Okay, 8421 here, same. Okay, now how do you convert, how do you write 32H, sorry, 3 digit 3? First you take first digit 3. How do you write it in binary? 0 0 1 1, correct? 0 0 1 1. And next, how do you write 2? Second, now take the second digit 2. How do you convert it in binary? 0 0 1 0, right? So this is what decimal, that is hexadecimal to binary, hexadecimal to binary. So now how do you write this? 0 0 1 1 space 0 0 1 0 H. See, observe this, there is a space here in between 2 4 bits, that is we call it as nibble. That is 1 nibble is equal to, I'll write here, so 1 nibble is equal to 4 bits. Okay, 1 nibble is equal to 4 bits. 4 bits, right? And then, so now how many nibbles are there? Here you can see 2 nibbles, 1 and 2, 2 nibbles. And H stands for sorry, H, replace this H by B, not H, that is B, binary. So this is binary number. This is what binary equivalent of 32H, hexadecimal number. And hexadecimal number 53H. Now how do you write this? 1 sorry 0 1 0 1, okay, space, now take second digit 3. So this is what? 5. This is 5. And now say take second digit 3. So how do you write now? 0 0 1 1, and now this is what? Binary. 0 1 0 1 space 0 0 1 1. This is binary. So here again similarly 1 nibble is equal to 4 bits, right? So how many nibbles are there? 2 nibbles. Done. And now similarly, can you try for 127H? So what you have to do now? You had to leave space now. 1 2 3 4 5 6 7 8, and had to leave space like this. So now 8 4 2 1, right? And then pipe in between. Okay, and here okay, fine. So now you what you have to do, first take first digit and write 0 0 0 1 0 0 0 1, and similarly write, say, take second digit to type 0, that is here, take second digit to 0 0 0 0 1 0, and 0 0 sorry 0 1, that is set as third digit, that is 7, and convert it to binary. 0 1 1 1, correct, is equal to so now 0 0 0 1 1 and 0 0 1 0 2 0 1 1 1 7, right? So this is what binary equivalent of 127H. Okay, and then now conversion from decimal to hexadecimal. How do you convert this decimal number to hexadecimal? So you have to follow some procedure. Please observe this carefully. Okay, so 25D 25D 25 takes a 25, D stands for decimal. Okay, 25 divided by 16 is equal to 25 divided by 16 is what? 25 divided by 16 is 16 ones are 16, and what is the remainder? 25 divided by 16 is what? What is the remainder? It is 9. 9 is the remainder. 9 is the remainder. Now see here, this digit. Okay, the answer is less than 15. If the answer is less than 15, then you don't have to simplify it again. So the final answer is what now? The final answer is 1 answer and the remainder, that is remainder is 9. So now what is that? 25D is what? 25D is equal to 19H. This is the answer. So 25D is equal to 19H. So here 1 is less than 15. Okay, so you don't have to simplify it again. So now let me take this example. 53 divided by 16 is equal to 53 divided by 16. What is the answer? 3. And what is the remainder now? Remainder is, what is the remainder? 16 3s are 16 into 3 is 48. 48, 53 minus 48, that is 48, 49, 50 plus 5, 5 remainder, 5 remainder, 5, done. And then so now since 3 is, see this one, 3 is again less than 15, so you don't have to simplify it again. So 20, so 53D is equal to 53D is equal to what? 30. Answer is 3 and remainder is 5, 35H. And similarly 127D, how do you convert this 127D now? How do you convert 127D? So 127 divided by 16 is equal to 7. So 7, what is the remainder? So this is the answer. And what is the remainder? 127 divided by 16 is equal to 7, and remainder is 16 into 7, 112, 112, 122, 123, 124, 15. So 15 remainder. 15 is the remainder, right? And then now see this answer. 7 is less than 15. 7 is less than 15, and 15 is what? Less than or equal to less than 15, less than or equal to 15, right? So you don't have to simplify it again. Here what is the remainder here? 15 remainder. 15 is equal to 15, so again you don't have to simplify it. So but how do you write, since it is 15, how do you write it in hexadecimal F, right? So that is the reason. So now here I'll write 127D. 127D is equal to, what is the answer? Answer is 7. So first write 7. Okay, and then how do you don't write 15, this is wrong. Okay, 15 converted to hexadecimal 7F. So it means what? Binary, that is decimal equivalent of hexadecimal equivalent of 15D is what? It is F. So 7FH. So answer is 127D is equal to 7FH. Okay, so let me check this now. So this is what this is programmer calculator. Okay, it is not simple calculator, standard calculator, it is programmer. In Windows 10 it's available. Okay, just programmer calculator. Here you can see hexadecimal, decimal, octal and binary and all. Okay, so let me keep it in which number? Decimal number. So let me type 127 here, 127. So what is the, you can see this one, what is that? 7F is the hexadecimal. What is that? Hexadecimal equivalent of 127 is what? 7F. Okay, that's what we got. Okay, so this next very important, this very important, 325D. 325 divided by 16 is equal to, what is that answer? 325. 325 divided by 16 is equal to 20. Okay, 20 is the answer. And then so what is the remainder now? What is the remainder? 20 into 16. 20 into 16, 325 is the remainder. 5 is the remainder, right? So now but here observe this 20, answer 20 is greater than 15 again. So that is the reason 20 divided by 16 is equal to 20 by 16 is what? 4. And remainder is what? What is the remainder? It is 4 again, right? 4 is the remainder. 4 is the remainder, right? So now what is the answer? Answer is like this: 4, 4, 5. Answer is 445. So 325 divided by 16. Okay, let me write 325D. Okay, is equal to 325. See this? What is the answer? Sorry, 16 ones are. I'm really sorry. 16 ones are. 16 ones are 16. What is the remainder? 14. So that is the reason 145. So 145 D is 145 H is the answer. H stands for hexadecimal. Done. So 325. How did I get this? 20 is greater than 20. This answer, this first answer is 20 is what? It is greater than 15. So that is why divide by 16 again. And now the answer is 1. Okay, 16 ones are 16 and the remainder is 4. So since 1 is less than 15, you don't have to simplify it again. So now the answer is what? 1, 4 and 5. Right? That is the answer. 1, 4 and 5. This is hexadecimal equivalent number. Now similarly, let me try this 568. 568. 568 divided by 568. 568 divided by 16. 35. 568 divided by 16 is what? It is 35. Right? 35. And then what is the remainder now? What is the remainder? 560. 35 into 60 is 560. So the remainder is 8. 8 remainder. Right? And then since 35 is greater than 15. 35 is greater than 15. So 35 divided by 15. Sorry, 16. 35 divided by 16. Okay. So see, 35 is greater than 16, not 15. Don't call say 15. It is greater than 16, right? So then, so now here 35 is greater than 60. So 35 divided by 16 is what? It is 35 by 16. 16 to the 16 to the 32. The answer is 2. And what is the remainder? Remainder is 32, 33, 34, 33. 3 remainder, right? So now 2 is less than 16. So you don't have to convert it again. So the answer is what? 2, 3, 8. Like this. 2, 3, 8. Okay. So this is the answer. So now how do you write this? 568. 568D. 568D is equal to 238H. Done. So let me check this. 568. Sorry, 568 is equal to, you can see the answer now, 238, correct? Yes. Similarly, can you try this and comment below? Please comment the answer. So this is what and this also 375D. Okay, solve this 375D, 1024D and 1567D and comment the answer below. So now here how to conversion from hexadecimal to decimal. How do you convert hexadecimal number to decimal number? So you already know hexadecimal number is what? 32H here, 32H. So wherever you see first you convert it to binary. You know how to convert it to binary, right? So this is hexadecimal to decimal, right? Okay, first you convert this to binary. Okay, let me place, copy, paste and paste. Fine. So now how do you write 3 now? How do you write 3 in binary? First, this is not required for us. Here I'll put 0. I'll just put 0 here because 032, right? 032, like that. I'll put 0 and here 3. How do you write? How do you convert? Take first digit 32. We had 2 digits. Take first digit, that is 3. Okay, take this 3 and convert it to binary. 0 0 1 1 and here also 0 0 1 0. Done. And so this is what? Binary number, right? Now add this. Wherever you see 1, take those position and add it up. Now how do you convert? Now 1, you can do not add like this 2 plus 1 plus 2. This is wrong again. Okay, now you first write the position here, that is number 0 0 0, that is 1 1 1 1 1, because however this is zeros, right? Just ignore these zeros because we don't have any ones here. Okay, at this part, so all are zeros only, so just you can ignore this. And then 1 1, sorry, here 1 1 space 0 0 1 0. I have considered only this part. Okay, so now 1, this is 1 2 4 8 16 32. 32, this is 32, right? 32 plus 16 is what? 32 plus 16 is 48. 48 plus 2 is what? 50. So answer is 50D. Okay, so means what? Decimal equivalent of 32H is 50D. That is the meaning. Okay, let us check this. So first, now hexadecimal, right? Just click on this 32H. So what is the decimal equivalent? You can see the answer 50 here. So this is correct now. So similarly, I'll try this now. 0 0 0 1. This is 1. And similarly 2 0 0 1 0. And next 7. Third digit is what here? 7, right? So how do you write it? 0 1 1 1 is equal to, so now ignore these 3 zeros now, okay, because we don't have any ones here. Ignore this. So now I'll just write 1 space 0 0 1 0 space 0 1 1 1 is equal to, so now take these numbers 1 2 4 8 16. So take 16, 32 64 128. So 128 plus 32. So first write 128. This is 128, right? 128 position, and this is 1 1 0 1 2 4 8 16 32 plus 32 plus 32 plus 1 2 8. 1 plus 2 is what? 3. 3 plus 4 is 7. So 7. If you add everything, then you'll get decimal number. That is 128 plus 32 is what? 150, 160, 167D. 167D. This is the answer. Right? Let us check the answer now. So 127H. 127H is what? Decimal equivalent is 295. 127H Here let me check. 1 2 7. 1 2 4 8 16 32 64 256. Sorry, this is 256. Sorry, 256 plus 32. The 256 plus 32 is what? 288. 288 plus 7 is 295. 295, is it correct? Yes, 295D. This is the answer, right? So this is how we convert hexadecimal to from hexadecimal to decimal. And next we'll see this one, conversion from binary to decimal. Conversion from binary to decimal. So we have binary number. These are the examples I've taken. So how do you convert these binary numbers to decimal now? So please try this out. In the previous example, how do you convert 53H to a decimal number? Okay. And next, and here decimal number, right? Conversion from binary to decimal. So 1 plus 4. Wherever you see 1 here, pick those ones. Okay, here 1 is there and here 1 is there. So pick these two. 1 plus 4 is what? 5. 5D. Okay, and then similarly here, so 2 plus 4, 6. 6 plus 8, 14. So answer is 14D, decimal. Okay, D stands for decimal. And here similarly for this, 1 plus 2, 1 plus 2. Here I have written the position, bit position. Okay, you can see this and write the answer. So this is simple. 1 2s are 2, 2 2s are 4, 4 2s are 8, 8 to 16, 16 to the 32, 32 2s are 64, 64 2s are 128, like that. And here 1 plus 2 is 3, 3 plus 32 is 32 plus 3 is 35, 35D, decimal number. And here similarly for this one, how do you write this? 128 plus 64, 180, 192, 192 plus 8, 192 plus 8 is 200, 204, 205D. So answer is 205D. Okay, so what about this now? Conversion from binary to decimal, right? So how do you write this now? 1 2 4 8 16 32 61 128. Add everything now. You have to add everything because we don't have any zeros here, right? So we cannot ignore any decimal positions. So add everything to get 255D. This is the answer. Let me try this. Here I'll take binary now. 1111 1111. So you can see the space in between here, right? In between these two. So 1111 1111. So what is the decimal equivalent? 255. Here left side you can see the answer, 255. And hexadecimal is what? FFH. So how do you write this in a hexadecimal number? This is F, right? And this 1111 is again F. So how do you write it now? FFH. H stands for hexadecimal number, like that. So similarly, try to convert these 205D to hexadecimal. You already know this. I already explained this, right? So please convert this and tell me the answer. Okay, please comment the answer below. Yes. And then here, conversion from binary to hexadecimal. How do you convert this binary to hexadecimal? Here first we have first write this one. This is the example I have taken, and you know, already I told you this is what binary position. How do you represent it? How do you represent binary position for hexadecimal? 1248 1248, like that. Okay, this is for hexadecimal, right? So now this is an example I have taken. So since it's hexadecimal, first here this 0 double 0 double 0 is what? 0. Write it here, and then take this next bit. 0101 is what? 4 plus 1. 4 plus 1 is 5. So write 5. So the 05H. This is the hexadecimal equivalent. Now take this 00, the 0. Okay. And how do you write 1110? 1110. 8 plus 4. 8 plus 4 plus 2. That is 14. So how do you write 14 in hexadecimal? It is E, correct? E, 0EH. Yes. And next, similarly for this one, take 2, this is 2 and this is 3. So 23H. Yes. What about this? Please find out and tell me the answer. Yes, what is the answer for this? Tell me. Okay, next. If a computer is 8-bit machine, yeah, this is very important, very important. If a computer is 8-bit machine, however, most of the computer nowadays use 64-bit, right? So, but if a computer is 8-bit machine, then so this what up to highest decimal number is what 128. Okay, so this 128, this 128 bit is called as MS bit, that is most significant bit, most significant bit. And this most significant bit, that is MS bit, this MS bit indicates what is that signed number, means what sign, it indicates the sign of the number. If this MS bit is 1, if this MS bit is 1, here you can see 1, right? If this MS bit is 1, the number is negative. When only if a computer is what is that designed for 8-bit machine, 8-bit. Okay, so the this bit is will be considered as sign bit. Okay, one this MS bit will be considered as sign bit. Okay, if MSB bit is equal to 1, I'll write here, if for this particular case, if MSB is equal to 1, number is negative. If MSB is equal to 0, number is positive. Okay, positive. So here now tell me what is the answer for this now. 0, the MS bit is 0, so however then it is plus only, plus. And here 8 plus 4 plus 2 is what, it is 14. How do you write 14 now? It is in this is decimal value, right? It is decimal value, so write 14 D plus 14 D. Okay, here this is I am converting from binary to decimal. Okay, and here similarly for this one, so now take second example. This the MSB bit is what, 0, so plus, put plus here. Next, here 32 plus 2 is 34 plus 1, 35, 35, 35D plus 35D. Next, similarly, now here it is minus, so the number is negative now, minus. And now add this. If you add this, it becomes 64 plus 8, 72, 76 plus 177. So number is minus 77 D, decimal. D stands for decimal. And then similarly for this one, this is 1, so number is negative, right? And what about this? This is 127. You can add this. When you add these numbers, 64, 32, 16, 8, 4, 2, 1, then you'll get 127 as answer. Okay, 127. And how do you write this now? How do you write this? Minus this one 0000101, so 128, sorry, not 120, minus this this MS bit indicates negative, and here 4 plus 1 is 5, so 4 plus 1 is 5, 5D minus 5D, very simple, right? So this is what conversion from conversion for 8-bit machine. Okay, if a computer is 8-bit machine, this is how we have converted a binary number to decimal number. So now you know how to convert decimal to hexadecimal, yeah, right? So and that you write the answer. Okay, please comment the answer below. Okay, comment it below. It's all about conversion from uh, decimal to binary, binary to decimal, hexadecimal to binary, hexadecimal to decimal, decimal to hexadecimal, and so on. Hope you have understood. If you have any doubt, please comment below. Thanks for watching.